software craftsman at JPoint in the Netherlands. I'm currently working for Malmberg, which is an educational publisher, where our experience for Vert.x range from. And in my spare time, I'm also user group leader for NLJUG, the Dutch Java user group. Any NLJUG members in here? All right, looks like I got work to do. Okay, this is not about NLJUG. So the next 40 minutes, I hope I will make it in 40. Short introduction of the situation where we're using Vert.x in, why we're using Vert.x. I'll do lots of demoing and live coding to show you the basics and some advanced stuff of Vert.x. And I'll, of course, talk about building microservices with Vert.x and tell you why I think Vert.x is a very good platform for building microservices. And I'll share our experiences with Vert.x. So Malmberg is an educational publisher. It's situated in Den Bosch in the south of the Netherlands. So an educational publisher traditionally makes books, but Malmberg also makes, we'll call them digital books. We make e-learning applications used by primary education, secondary education, and professional education. These are used by students to perform exercises and to learn new topics, and for teachers to plan assessments and to see the progress that students make. These are fairly modern applications. We're using Java 8, Vert.x, MongoDB, AngularJS. Everything is running on the Amazon cloud in Ireland, so we actually have no idea where our servers are, somewhere across the pond in Ireland. And we have a fairly modern and skilled set of development teams there. There are 10 teams building different applications, all in the educational domain. So let's get started with Vert.x, the basics of Vert.x. As the Vert.x team explains it, Vert.x is a toolkit for building reactive applications on the JVM. It's very general purpose. It's unopinionated. You can build everything you like with Vert.x. You could also call it somewhat a Swiss Army knife for building modern cool stuff. We use it to build web stuff, which you can build other stuff with it too. Everything's event-driven and non-blocking, which makes it very high performance. I'll go in more detail about that later. It's also polyglot, so you can build Vert.x applications with multiple languages. It's very lightweight, it's very fast, and I personally, as a developer, really like to work with Vert.x. So why did we choose Vert.x? And by saying we, I mean Malmberg. We love open source stuff. I think everything. The only thing we probably pay for is our GitHub account and our Atlassian suite. But all the rest we use is all open source. Jenkins, Nexus, Sonar, Fitness, Nginx, Linux. Most of we use is open source because we love that it's free. Free as in free beer, but also free that we can take a look at the source and understand how stuff works. Vert.x has a powerful module system, and this really works good for Malmberg because while there are 10 projects building applications, they all share the same characteristics. You build application in the educational domain, which means you have to do something with educational content, the questions you ask students, and assets, movies or images you show to students. You also need to do something with session management and profile management. So we wanted to build generic modules and then reuse these modules over those 10 teams. And we also chose Vert.x because of the reactive characteristics. So we did this like 3 years ago. I don't think that microservices, I'm not sure whether microservices were coined as a term by then. It wasn't a reason for us to choose for Vert.x. We chose it because of its reactive characteristics. Who's ever heard of reactive programming? All right, so most of you. So a short wrap up. Reactive programming is built around 4 pillars. The first one is making your application responsive, which means it reacts to the user. It responds to the user in a timely manner. Secondly, it is resilient. It reacts to failure. When something fails in the application, it should be resilient against those failure, and in the best case, let the end users not notice the failure. It should be elastic, which was previously called in the reactive context scalable. Elastic means the application reacts to a varying workload and responds by scaling. And reactive applications are event-driven, which means they use asynchronous message passing to create boundaries between the different components in a reactive system. So enough of that. Let's start with the first demo. I'll be showing you some code examples with Vert.x. It'll be here in a second. All right, so let's first start with a basic hello world application. This is readable, should be right. My first Java vertical. So the unit of execution in Vert.x is called a vertical. Vertical is basically a simple Java class which extends from the Vert.x base class, which is called abstract vertical. So a vertical has a start method, which is called when the vertical starts. This overrides from your abstract vertical. And you have an instance variable called Vert.x where you can access the Vert.x API. So let's create an HTTP server and create a request handler that handles requests. When we get a request in, we say request, get the response, and end it by saying hello world from Java. Let me line it up a bit so it's more readable. And tell the server to listen at port 8080. So this is one of the simplest verticals you can create. Let's fire this up. Let me show you this in the background. Or not. I want to go here. Well, anyway. Let's see. Hello world, Java. And here is my first Java vertical I just created. So I can use Vert.x. It's a Java project, but this as an executable you can run on your system. Vert.x run my first Java vertical. And note that I'm running the Java source. I'm not running a class, I'm just running the Java source. And Vert.x will compile it and run it for me. If I now go to localhost 8080, it will say hello world from Java. So that's as simple as it can get. I'm using Vert.x to run a Java source file to create a web server and send a response. Not a very enterprisey application yet, but well, we get to the enterprise in a bit. Any developers here? Any Java developers in here? All right, so you must understand it on example. Any Groovy developers in here? A few. So as I said, Vert.x is polyglot. So the Vert.x APIs are generated in a multitude of languages. Java, Scala, JavaScript, Groovy. So if you take the Groovy example, it basically looks kind of the same. Vert.x create HTTP server, create a request handler, and send hello world from Groovy. So let's dive into that one too. It will now compile the Groovy source and run it, and then we'll get the same thing, but from Groovy. Any JavaScript developers in here? Right, you might guess which is the following example. A JavaScript vertical, which looks pretty much the same as the Groovy vertical. And you see there's a bit difference in the function definition, but the rest is fairly similar. Let's fire up the JavaScript vertical. It takes some time because it will, in the background, fire up Nashorn and then run the JavaScript script on it. And we have hello world from JavaScript. So the API is pretty similar for the different languages, and you can pick the language you like to write verticals. You can also embed Vert.x in your application. So now I've just created a simple source file and ran it with Vert.x. But you can also embed it. So I have a embedded Java vertical here, which is just the main method. And you create an instance of Vert.x by calling Vert.x.Vert.x, and then it basically does the same as I did before in the vertical that was running by itself. Let's see if I stopped the JavaScript vertical now. Let's do it and then run it. So I'm just running this main method. And then Vert.x will start up, and now I will have the same, but running from embedded Vert.x. So you can easily create, for example, self-contained jars here, or embed Vert.x in some other project. About those jars, let me stop it here. By using a Maven plugin, like for example the Maven Shade plugin, you can create a self-executable jar that will call this main class when you start it up. So I happen to have set that up here. I'll package it. See if this is not running anymore. No, so it's not running anything now. Now I'll fire up the jar. You can see that there's a jar with the Vet extension here. This is a jar where all the dependencies have been baked into. So this is a self-contained jar, including Vert.x, all dependencies, and my Java class. If I fire it up, I now have the embedded Vert.x running from this executable jar. So it's that simple to create a jar that you can just put on a machine with only Java and then run a web server. Back to the slides. So let's go into a bit more depth about Vert.x. If I would end here, you would probably be very disappointed about what Vert.x can do for you. So Vert.x has a number of levels of abstraction you can use to create your application. The unit of work is a vertical, which I've just shown you. A vertical runs in a Vert.x instance, which is just Vert.x starting up one or more verticals. You can either run one vertical in a Vert.x instance or multiple. A Vert.x instance runs inside a JVM, and a JVM runs on a host. So we typically run a Vert.x instance with only one or a few verticals, so we can tune the JVM settings for those services independently. So these two JVMs in this case run on a host, and there's a distributed event bus connecting the JVMs together. So the event bus is one of the core features of Vert.x. It's like a messaging, asynchronous message passing system. And this event bus makes that the one verticals in one JVM can connect to verticals in the other JVM. So you can send messages between services. And in here, it's all running on one host, but I've made very dynamic slides, and I'm now going to split the host in two. Wait for it. There it is. So now we have two hosts. If you're running on different servers within the same network, the event bus automatically clusters and links those JVMs on those hosts together. So you can even run a multitude of machines within the same network with verticals and JVMs on each machines, and they will automatically discover each other and connect to the event bus. So a bit more in-depth about Vert.x. It's, as I said, it's event-driven and it's non-blocking. And one of the main features of Vert.x is an event loop. And the event loop is implemented using the multi-reactor pattern. The reactor pattern is something that's used in Node.js, for example. It's an event loop that constantly runs over all the events in your application and then handles the events one at a time by directing them to the appropriate event handler. And this makes that with only one thread, you can handle thousands of connections because those connections won't have work to do at the same time. So compared to a different, more traditional model where you have one thread per connection, the reactor pattern allows for a lot higher concurrency on a machine because you use a lot less threads. So when in the reactor pattern, like it's used in Node, there's one event loop running, constantly looking at the events to handle. When there's an event to handle, it directs it to the appropriate handler, and then continues with the next event. This doesn't scale too well on multi-CPU systems. So Vert.x implements the multi-reactor pattern, where there are created by default as many event loops as there are cores on the machines. If you have 4 cores, you have 4 event loops. And the cool thing about this, besides from sounding pretty complex when you first start to work with it, which isn't cool, but the cool thing is that this creates some kind of like a actor-like concurrency. Anyone of you has worked with actors, like with Akka before? So the cool thing about this is that the event loop and the handlers Vert.x will make sure that every handler is always only accessed by one event loop at a time. So you won't have any concurrency on that handler. And usually one handler is only accessed by one and the same event loop. So this makes for a programming model that's fairly close to being single-threaded. You don't have to worry about synchronization, you don't have to worry about locking and concurrency. You can just write your applications as being single-thread applications. And that's really useful when writing high-performance web applications. There is one catch, which I'll be telling you later, but an event loop that's constantly processing events and directing to handlers, that's what Vert.x does with the multi-reactor pattern. So there's a distributed event bus. This event bus I'll be demoing later, which makes that all verticals are connected to these event bus and they can send messages to each other. And there's all sort of other cool stuff like managing and monitoring is built in using drop wizard metrics. There's a whole lot of modules you can just grab from the Vert.x side and throw into your app. So about the event bus, it supports both a single-way communication, so request response, but also publish subscribe, where you can publish to a topic, subscribe to a topic, so that's like multi-request response. Messages on the event bus are received by handlers. Basically every event in Vert.x is handled by a handler, and these verticals interact by sending messages and sending them to the event bus. So what I showed before, the request handler, where there's a request coming in and then being handled, that request is an event itself. So everything is an event in Vert.x. So there's one important rule when you're working with an event loop, and that's to never, ever, ever block the event loop. Because say the event loop is handling like 1,000 connections, by just hopping over events and directing them to handlers really, really fast. And then one of those events start blocking the event loop. And all those 999 events will have to wait before that one event has been processed. So if you really want to achieve high concurrency and basically have a working Vert.x setup, you should never, ever, ever block the event loop. So when you need to do blocking stuff, like going to disk, they're actually asynchronous APIs at Vert.x, but call an external web service or do something that go to your database. Never do it on the event loop, but use a traditional thread-based approach, which you can achieve by using a worker. A worker can either be a worker vertical, then everything is run on the on a thread pool, separate thread pool, or you can run a separate piece of code on a worker thread. So you can just write asynchronous code in your vertical and then do something that's blocking. You can say direct this to a worker thread, and then Vert.x will make sure that this is handled on a traditional thread pool, not blocking the event loop. So let's put Vert.x in one slide. This is actually a slide that I borrowed from the Vert.x team, with their permission, of course. Vert.x is polyglot to start with. So you can use JavaScript, Java, Groovy, Ruby, maybe even PHP, I'm not sure. You got verticals. Every piece of code in Vert.x is a vertical. And everything that happens inside Vert.x is an event. So it can be a message sent from a vertical to another vertical. It can be a HTTP event. It can be an event for a queue. Basically everything is an event. These events get delivered by event loops over the event bus to handlers. And these handlers can, of course, be polyglot. So you get this interesting mix of writing asynchronous non-blocking code in different languages on different machines and in different JVMs and different processes. So this is very flexible, and we'll make sure that this is one of the reasons that Vert.x is so unopinionated. You can basically do everything with it. If you were to put a man on the moon, I would probably use Vert.x for it. It's a good thing I'm not putting people on the moon, because there are all the things you need to know for that. So it's time for the next demo. And in this demo, I'll dive a bit deeper into Vert.x by showing you how the event bus, the Vert.x event bus works. All right, so let's start with a basic example. I have a Vert.x starter, which is just a main method starting embedded Vert.x. And this will deploy two verticals using the Vert.x API. It will say deploy an echo service and deploy the web vertical. This echo service is a fairly simple service. As you might guess, it just sends a reply back to the caller and inserts a marker in there. So this is a vertical. It has a start method. It will start by telling Vert.x, hey Vert.x, get me the event bus and register me as a consumer of events. I'm going to consume events for you. Register me on the echo service vertical address, which is just a string. And when a message comes in, do whatever is between these curly braces here. So when a message comes in, we grab the body of the message, which is JSON, a Java representation of JSON. It's a convention in Vert.x to send all the messages over the event bus as JSON objects or as strings. But JSON objects are a bit more versatile than strings. So I'm grabbing the message body out of the message. I'm logging that I received the message. Then getting the JSON object and putting another key in there, which is called pass through echo service, so we can see that it passed through this service. Log the reply and then send the reply back to whoever called the echo service. So then there's a web vertical. And this is basically the same as the first example I did. Create a HTTP server, put a request handler in there. When a request comes in, do whatever is in here. So I create a JSON object and put two keys in there, a text and the query string from the request. Logging the message I'm going to send, get the Vert.x event bus, send a message to the Vert.x event bus, to the echo service, put the message in there. When a reply comes back, read the body from the reply, log it, and then send it back to the response. So web request comes in, message gets created, sent to the echo service inserts something to it, send it back to the response. Let's see what this does. There's something already running, which is probably my own fault. Yes. Let's see what it does now. All right, so it should be started up now. Let's go to localhost 8080. And we can see that the response that's being sent is somewhat like the JSON object I was wanting to build. So let's see what's happening in the logging. So the web vertical has sent a message with a text and a nil query string. Then the echo service has received a message, the same thing. You can see that the keys here are in different order, but that's not really significant in JSON objects in this case, so not a problem. Then the echo service sends reply. It's the same message, but it has inserted the pass-through echo service message. And then the web vertical has received the reply and sends it back to the HTTP response. So let's put something in there so that you can really see that this is doing something with something that's in my request. Key is value. So now the query string is read from the request, sent to the echo service, and sent back. So this is a fairly simple example, I hope. Who agrees that this is a simple example? Oof, all right, because we're going to get a bit more complex now. But this is very powerful because this enables you to just create a very small services that listen on the event bus and do stuff when they're exited and send stuff back. And these can also be built in different languages. So the echo service I could easily implement in JavaScript or in Groovy or in Scala or in Ruby if I would like to. So that was the basic event bus. There's one drawback with this event bus and asynchronous stuff, and that drawback is called callbacks. And who's ever heard of callback hell? Okay, keep your hand up if this happened when using a node. Oh, right, about half of you. Okay. So when you are sending events to different services and you have to combine those events, it will get messy pretty quick. So we also have a starter which starts embedded Vert.x, fires up 3 services, and then starts a web vertical. So these services are not very useful. The first one just replies with reply from service 1. So it listens to the event bus, it registers itself, when the event comes in, it replies reply from service 1. You can probably guess what the second service is going to do. Basically the same, but say reply from service 3. Now you can probably guess what the third service is going to do. Ah, gotcha. It's doing something slightly different. It will take the message from the body from the message and then add pass through service 3 to it and then respond with that message. So what can we do with this? What I want to demonstrate is that I have a use case where I'm running a web server, and when a web server gets a request, I want to call one service to get something from that service. I want to call a second service to get something from the second service. I want to combine the result of those 2 services, send it to the third service, and then send response back to the HTTP response. So 2 service calls, wait till they are done, call a third service, and send the combined result back. So if we were to program this with default callback style in Vert.x, it would look something like this. Send to service 1, message to service 1, and save the reply as a string. In this case, I'm just sending strings instead of JSON objects to make things a bit simpler. I could send 2 messages in parallel, so one to service 1 and one to service 2, but then I would need to have a mechanism to wait for them both to finish and then combine them together. So it's a bit easier to send a message to one service, wait till it has returned, then send it to the second service, so you know when it returns, both service calls are done. So when the reply from service 1 comes in, I'm sending a call to service 2 and saving the reply from service 2. Then combine the results just by concatenating them and send the combined result to service 3. And then send an HTTP response with the response from service 3. So this should look something like response from service 1, response from service 2, pass to service 3, right? So let's see what happens. I think that I still got something else running. Yes. Let's start the callbacks starter. Right, so here we are. So it has a response from service 3, which is called reply from service 1, reply from service 2, pass through service 3. So this is the combined result from 3 service calls. Who of you really likes this nested callback structure? No one? One, all right. Congratulations. I don't really like this, and this is a fairly simple example, but it can, when you need to call a few services in a chain and do something with the results, it can get pretty annoying pretty quick. And this prevents you from doing stuff in parallel. For example, if service 1 was a very long processing service, and service 2 was very long processing too, then I would have to wait for both services to complete before I could go to service 3 in this case. If I would be sending them in parallel, I could send a service back once they're both done. It will probably be faster than sending them sequentially. There is a solution for this. It's called Rx Java, which is the Java implementations for the reactive extensions for the JVM. Anyone has ever heard of reactive extensions? Right, about half of you. Reactive extensions work with observables. Observables are like futures, but futures are only for single object instances, while observables can handle streams of data. So observables are pretty awesome. Can be a bit hard to understand at first, but I like them. So I have the same vertical starter, which deploys the 3 services which you are now familiar with. And then it starts on Rx Java Web Vertical. So the Vert.x team loves Rx Java, and they've created, it can be a strange or dirty word, an Rxified version of the APIs. So all Vert.x APIs have also an Rx Java implementation, which makes it accept and work with observables. So think of observables like futures. So now I can send to the event bus the same call. So I'm sending to service 1, message to service 1, but I'm now using send observable. And this replies with an observable. So this is like a future that will be completed once the service completes. I can directly call the second service and then send a message and reserve an observable too. Then I'm telling Rx Java to zip the results of those 2 observables. And zip means when these are complete, apply this function to them. And what I'm doing is I'm saying when you get the first response and a second response, get the body and concatenate them together. Basically the same as I was doing with just a string concatenation in the callback example. So once I've got this combined, I can then subscribe to this observable. Subscribing means do this when it's complete. And then send the combined result to the Vert.x event bus to service 3. Once that completes, I can respond to the HTTP response with the combined result. So if you compare those two, there's a lot less depth in the level of nesting. It's also shorter. I think it's also more readable, but you need to get to know the RxJava API for it to become readable. So let's fire this one up and see if it does the same. If I can click, yes. So that's running. I'll open it in a new tab so you can see the results. So it says now the RxJava vertical response on service 3, and this should be actually this kind of the same reply as from service 2, from the callbacks variant. Yeah, so that works. So RxJava is really helpful here to make multiple service calls a bit more, a bit less painful. You can also do it shorter. You can do it in a one-liner, if you like, where you will call the event bus. Let's fix the imports here. Say Vert.x send to the event bus this message, zip it with the second message, then apply a function, and then subscribe to the combined result and respond it back to the HTTP response. Well, the good thing maybe about this that it fits in one line of code. The rest I think is not really that good because I think it's less readable than defining separate observables. But that's something to your own taste. Let's see if this works too. Demonstrate it. So the one-liner will also respond with reply from service 1 to pass through service 3. So that was about RxJava. There's one more example I'd like to show you. The cool thing about the event bus is that you can also, we typically only use it server-side, but you can also extend the event bus all the way to the browser. So the browser in JavaScript can communicate to the Vert.x event bus. And that's, I think, pretty cool. So I've made a small demonstration. This is all the HTML I'll be showing. What this does is it imports stock.js, which is used to communicate with Vert.x. It includes the Vert.x event bus implementation in JavaScript. And then you can just say, wow, my friend, get me the event bus. And when the event bus opens, register a handler that will listen to that will subscribe to the events feed. And whenever an event comes in the events feed, take the events element in my HTML and append the date and the message to the contents. So then in this field, the message sent on the event bus will be added. So let's look at the implementation. I've got a starter that will deploy 3 verticals. It will deploy a very simple vertical that will start a periodic event every second and will say, hi, I'm Java. And there's the same thing in JavaScript. Well, let's not open that one, but this one. That will say, hi, I'll send an event every second and will say, hi, I'm JavaScript. So these are publishing events to the event bus every second. And then we got the sock.js event bus bridge, which is a vertical which when start will configure the event bus. It will start up a Vert.x router, which is the API routing mechanism in Vert.x. It will configure options for the event bus bridge, which will say there's one, by default, the browser is not able to access the event bus because that could be kind of a security risk if you expose your database over the event bus. So you can say there's one outbound route permitted and it's the address events feed. So this says verticals can send events outbound to the events feed. Then I'll route on the event bus, all on the event bus endpoint, create a sock.js handler and bridge with these options. I'll serve the static resources in the web folder, which I've just shown you here. And then I'll create an HTTP server which listens at 8080 and starts serving requests. So if I now fire this up, let's see here. It will start clustering because I'll be showing something else later. And if I now go to localhost 8080, we will see something happening. Yeah, so what you see here is the HTML in JavaScript in my browser connecting to the Vert.x event bus running on my machine over HTTP, and then the 2 verticals sending events to the event bus. This is actually happening over WebSockets, which I can show you by using Chrome. So let's go to the network tab, reload it. You can see that there's a call, well, I'm not sure if you can see this, but you need to believe me, there's a call to the event bus. Then here there's a WebSocket call, which there's a 101 switching protocols. I can't preview this now because there's still events coming in, so I'm shutting down the backend. Now I can take a look at this. Is this readable? Well, not really. You're going to have to trust me on this. So these are the actual WebSocket frames being sent. They're just JSON objects that are being sent over the event bus with some metadata, but very similar to the events that I'm producing. So the cool thing about this is that JavaScript, Java, the browser are all connected together, but they're all still being run from Java. So let's see what happens if I disable the deployment of the JavaScript vertical. What should happen now is that we will only see the Java events being sent, which is true. So now let's see what happens if I start the JavaScript vertical in a separate process. Go to the SockJS event bus, JavaScript, so here it is. I can now say Vert.x run simple vertical. What's going to happen? Any ideas? You might be surprised that nothing happens. Wow, why doesn't it send my JavaScript events? That's because we didn't tell Vert.x to start clustering. So by default, if a vertical doesn't cluster, you need to tell it to cluster. And when I tell it to cluster, it will find the cluster, the Vert.x cluster, and join it. So we should be seeing, you can see it here, no cluster specified. So when it's deployed, we should be seeing JavaScript events here. And there it is. So now we've got a separate process with a JavaScript vertical, a Java process with a web server and the browser, all happily connected together, exchanging messages. Well, isn't that nice? I think it's nice. So it's about time to start wrapping up. But before we do that, there's some more things I want to share you about how we're using Vert.x. So first about Vert.x and microservices. When we look at a microservice, it's typically small in size. It does one thing really well. It runs in its own process. It has its own data store, being a database or queue or something else. It's distributed by default. You can independently develop it, upgrade it, replace it, scale it. It's potentially polyglot. And there's lightweight communication between the services. So if we map this to a Vert.x service, take a look at the title of the slide. Nothing changes. The slide stays the same, but now it's a Vert.x module. Vert.x modules are all small in size. If you build them well, they do one thing well. They run in its own process. They can have its own data store. It's up to how you build it. They are distributed by default because of the event bus. You can independently develop them, have even different teams with different expertises develop them. Are they polyglot? Well, I think I just showed it. And they provide lightweight JSON communication over the event bus. So it turns out that Vert.x is an ideal platform for building microservices because it maps pretty good to all those characteristics while still being very general purpose and unopinionated. So how do we use Vert.x? A bit about our organization structure. We have one core platform team which arranges all our infrastructure and all our DevOps stuff. We have one core modules team which creates reusable Vert.x modules. We store as binaries in Nexus. And then we have product teams that build applications using those modules. So as I said, we run on AWS, we use Mongo, we use Nginx. And an application typically consists of multiple lightweight artifacts, like 1 or 2 Vert.x services from the team, from the product team, and then sort of 8 from the core modules team. Database connections, profile management, session management, content service, all stuff like that. There wasn't really good deployment tooling for Vert.x, so we had no other option, or well, there were other options, but we like to build ourselves, what we've done. You can find it on GitHub. This is fairly advanced stuff. We have a Jenkins plugin to control these deployments. We have agents running on our machines, which are Vert.x agents itself. And Jenkins calls this agent. The agent will then fetch the artifact with a deployment descriptor. The agent will then fetch the artifacts from from Nexus, and then we'll start installing them. There's communication with the AWS API in there, so we do deployments node per node, and we can do this using zero downtime by communicating with the AWS API by saying, get this one in standby for now, deploy, wait till it's back up again. And we deploy microservice-wise only those services that are changed, so we can do really fast deployments, only deploy those services that have changed. So it's very suitable for TDD. There's excellent integration test support, and we combine this with embedded MongoDB, which works pretty well. And we got good cooperation from the Vert.x team. Actually, one of the guys lives in the Netherlands. We had some challenges, of course. The callback hell. Java 8 helped us a lot there by using lambdas instead of creating anonymous inner classes. And RxJava fixes the remaining issues. I'm out of time, but I've only got like one minute to talk, so you're free to leave. You're also free to stay. Mark, I won't hold up your talk too long for afterwards. Blocking the event loop, we did it. We noticed it. It broke stuff. It's hard. You need to be very thoughtful about this. Vert.x 3 notifies you when you block the event loop for more than 5 minutes or so. So that's a good improvement. Scaling and JVM overhead. When you're running 8 modules on 8 JVMs, you have 8 times the JVM overhead on a machine, which is like 32 or 40 megabytes to start with. So this makes it kind of memory intensive, but well, it's all right for us. Debugging is hard because all the event loop and the messages, there's no clear static code path to the application because there's being messages sent to string addresses. And this also makes static code analysis hard. For example, security scanning tools, like the ones from HP or from Veracode, they follow static code paths to your application from request to response and see if there's tainted data in there. Once it ends at a event bus call, the analysis stops because it can't follow the event bus path, so that's difficult. And the upgrade from Vert.x 2 to Vert.x 3 was a big one because the Vert.x team improved a lot, but they needed to break stuff for that, which was okay with us, but the larger projects have been running for longer, were a bit troubled by this and had to do a lot of work to upgrade. Most of the projects are now, I think about half the projects are now running Vert.x 3. They're very happy with it, very happy with the RxJava stuff. The rest is still upgrading. So as I said, almost there. Vert.x is a toolkit for building reactive applications on the JVM. It's polyglot, it's event-driven, and I think it's very suitable for building microservices. So further reading, all these examples I showed you are on my GitHub page. You can go to the Vert.x site, pretty good documentation. There's a blog in there, there are examples, and there's a link to the deploy tools there too. I'll tweet my slide deck just after this session, so you can click on the links there. So, there is actually not really that much time for Q&A, but if you want to ask a question now, I'll go ahead and have Mark set up his stuff, if you like, for the talk afterwards. And I can handle questions until it's time for the next talk. So if you would want to stay here, that's all right. My friend Mark is going to talk about very exciting stuff afterwards. It's going to be, I think, about Spring and Spring Boot and Spring Cloud, right? All that good stuff, so if you want to stay in here, sure. Any questions, I'm happy to take them now, or you can ask me on Twitter, or come look me up afterwards. I'll be here all day. I'll be doing one more talk after the afternoon. It's going to be about DevOps and process and stuff. Going to be fun too. So questions? Yes? Yeah. 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 So the question is, how does Vert.x compare to Akka? You know, there's the actor model. Actors have a life cycle, and actors are like small state machines that process actions. Well, I think they're comparable in the way they handle concurrency and threads. But the actor model is a lot different from the event model in Vert.x, where events are just messages being passed, and the application needs to determine how to respond on it. While in an actor model, you're telling an actor, which is a kind of entity like a shopping cart, to shopping cart, put this product in your cart. So I think the actor model is a bit more descriptive, and the Vert.x event model is a bit more open. They're similar in terms of concurrency, but a lot different in the way you use them. Any more questions? Yes, up front?
Yeah. What about the first sequence of messages if you want to choose Vert.x to develop the application?
Yeah.